Solar flares are features of the corona that occur usually above sunspots. Remember that a sunspot is down on the surface of the sun on the photosphere, so a solar flare is occurring in the atmosphere up above a sunspot. Even though it's called a flare, it can last up to 20 minutes. It doesn't just flash on and off. So this is an event which has lots of energy coming out of it that can last for 20 minutes, releasing all of this energy that puts it up to a temperature of about 40 million Kelvin, which is hotter than the core of the sun. We know it's 40 million Kelvin because we use our understanding of blackbody radiation in order to figure out what temperature it would be at by looking at its spectrum. And so because it has such strong emission in the ultraviolet and X-ray regions of the spectrum, this is an indication that you would have a 40 million Kelvin temperature. So if you tried to look at the sun in the visible part of the spectrum where a solar flare was occurring, you would not see that much happening, though you'd probably see the sunspot down below it. So with all of this strong ultraviolet and X-ray radiation being emitted out into space, there is a concern for our astronauts sometimes. If it's a C-class common type of flare, then that's going to emit lower energy types of ultraviolet and X-ray, and then moderate class emits more energy, and then X class emits the strongest types of X-ray radiation that can come out of flares. So we wouldn't want our astronauts to be encountering one of these if they were, say, on their way to Mars or something like that. Now when we look at this picture of the sun, we're looking at something which is green, and we should immediately say there are no green stars. That's not what the sun is supposed to look like. And that's a clue that tells you we are not looking at a visible photograph of the sun, something that's not in the visible spectrum. If you want to see a solar flare, you have to look in the ultraviolet and X-ray part of the spectrum. So looking at a photograph like this should give you a clue that you must be looking in a different part of the electromagnetic spectrum. And in this case, it's ultraviolet and X-ray. And right over there, that's where you're seeing the solar flare shooting out really, really bright from the sun. Something else that shoots out from the sun with lots of energy are coronal mass ejections. Look at all of this gas that is being pushed off the surface of the sun. Solar wind is always moving off and away from the sun, but you don't see solar wind in photographs because it's very thin amounts of gas. But this is a huge, thick amount of gas that's pushing up and away from the sun and is going to be ejected out into outer space. This is what makes it a coronal mass ejection. It's blowing out of the corona, emitting a huge amount of gas that's being ejected into space. If you ever hear a news story or see a news article that says something about a CME is coming from the sun, they are talking about a coronal mass ejection when they say CME. Now, we're saying over here that it's huge amounts of plasma that are lifting off into space. When a scientist is talking about plasma and they're talking about it in terms of physics and astronomy, then they mean the kind of plasma which is charged particles, mixed in with some neutral particles and atoms too. But a plasma has a lot of charged particles to it. And that's why they also interact with magnetic fields. So this is charged because it's been ionized from the terrible heat of the sun. And now it's going to rip off of the sun and over a period of hours push its way out into space, and it could even come towards the Earth. So even though it's joining the solar wind, it's more like a huge tsunami type of wave and really strong eruption in the solar wind. And if that manages to go in the right direction and come and hit Earth, how much trouble are we in? We'd have about 3 to 4 days of warning if we saw it coming, and we do continuously observe the sun, so we would see it coming. But when it comes to hit the Earth, it's charged particles that are affected by magnetic fields. So Earth's magnetic field is going to grab it and pull it down towards the poles. And that's where it's going to hit the atmosphere, and that's where charged particles are going to hit a gas. Just like electrons going through a fluorescent light bulb, it's going to light up the gas. And that is going to give you a big show of aurora. Northern lights. So actually, a coronal mass ejection is something that you might look forward to if it's not dangerously powerful, because you might get a chance to see northern lights if one of these things happens. Last feature of the corona that we're going to talk about are coronal holes. So again, we're looking at another picture of the sun. Doesn't look quite right. Doesn't look like the photosphere that I'm thinking of. So this is a clue that this is not in the visible spectrum. This is another picture that's taken in the X-ray or ultraviolet portion of the spectrum. And when we study the picture, we see lots of areas that are very, very, very bright. And then there's this one place over here that's much, much darker. So the bright regions means there's more energy building up there in order to send out stronger X-ray and ultraviolet radiation. You would get more energy when you have heat that's building up from gas that's being trapped. So remember, always on the sun, like with sunspots and the surface of the sun, hotter is always brighter. So heat is building up in these areas. But over here where it's darker, again, dark is like, it looks like a hole. Is it really a hole? Well, it's a place where gas is actually just being released instead of being trapped. Because the gas can be released, you're not trapping gas, you're not trapping energy, you're giving some relief to this portion so it can emit the energy and cool off. And cooler is always darker. Darker is something that people might call a hole. And that's what we mean by a coronal hole.